Good afternoon, sir.
Good afternoon. So yesterday we discussed about the models, right?
Yes, sir.
So how they arrived model you completely know, right?
Sir.
So we'll wait for some time.
Okay, sir. Okay, sir.
Okay. So you have any doubts? Now you can discuss with me and clarify.
No doubt, sir.
No doubts. So what is the demerit of the Thomas model?
Sir, that cotton balla or pudding, sir?
Pudding.
Sir, it was actually wrong, sir. What it said was the electrons were at the center and the protons were revolving it, but it was not like that. The proton, small proton, like called nucleus, will be at the center, and electrons will revolve to the proton.
What is the demerit of Rutherford model?
Sir,
Yes.
sorry, sir, I joined late.
Okay, no problem. What
The
is the demerit?
Rutherford model, if they don't have a particular orbit, they'll once they revolve, they lose their power and then they'll get into the nucleus.
Okay. Now we come to the conclusion that the atom is consist of mainly three subatomic particles. Number one, proton,
Neutrons,
neutron,
electrons.
and electrons. When you are considering electron and proton and neutrons, so first you have to see the characteristics of electrons. Electrons are negatively charged. Okay,
Yes, sir.
their charges are -1.
Nice.
When you are considering proton, it's positively charged. Okay, so they are positively charged. When for the neutron, it is a
Neutral charge.
neutron. So they point out that the neutrons are neutral charge, electrons are negative charge, and protons are positive charge. When you are taking an atom, so the atom which will consist of proton, neutron, electron. When you have these three, then you get the neutral one. So always, if how many number of proton you are having, that much number of electron if you have, that this nucleus is very stable. Okay. So in the nucleus, we say you have the proton and the neutron. Protons are positive charge. So what will happen? They will repel each other. Okay. So along with the neutron, to minimize the your proton repulsion. Correct? So when you are considering about the nucleus, so nucleus is made up of proton and neutron. This is the conclusion of the all other models. And then Bohr model also said that when you are considering the nucleus, from the nucleus you have particular radius of some energy level. That energy level only we are call it as K level, L level, M level, and N level. Am I right? So K shell, L shell, M shell, and N shell. So what they are representing? No, from the nucleus. So you have the orbit. That orbit having a particular radius. So it has a particular energy. From the nucleus, it has some large distance. The first shell will be there. That shell is K shell. In that shell, you can accommodate only 2 electrons. You can accommodate only 2 electrons. And the next shell, and then next shell means after the K, you have the L shell. In this shell, you can accommodate 8 electrons because here you can have 2 orbitals, sp orbitals. And the next shell, you can say it is a L shell, KLM M shell. Okay, here you have s orbital, p orbital, and d orbital. And the last one, you have KLMN shell. So One day I have drawn in the board. Do you remember? The
Yes,
nucleus,
sir.
first circle, second circle, third circle, and fourth circle. It goes and so on. Okay. Now we know that how you can calculate the atomic mass, how you can calculate the molecular mass. These are the things you know. Okay. So now you have to calculate number of proton, number of electron, and number of neutrons. Okay. So for all the element, for the particular element, the atomic number will not be changed. That means the number of proton will not be changed. Okay. You can take the hydrogen isotopes. Isotopes mean same atomic number,
Different
different
mass number.
mass number. Otherwise, you can say the same concept in the different manner. What? Same atomic number, different neutrons. Same number of proton, different number of neutron. It also gives rise to isotope. Okay.
Yes, sir.
So this is the conclusion we are at. Now all of you calculate for the lithium. Lithium atomic number is 3, mass number is 6. Now you tell me how many number of proton, how many number of neutron, how many
Sir,
number of,
can repeat?
for the lithium atomic number is 3, atomic mass is 6. Okay, you calculate number of proton, neutron and electron.
Sir, 2.
What is 2?
So 2 electron, 2 proton, and 2 neutron. Sir.
For lithium,
Yes, sir.
I said atomic number is 3. Atomic
Sir,
number
3
gives,
electrons will be there, right?
3 electrons and then 3 proton.
and then what is the neutron?
Neutron 0.
Oh, hello, mass number minus atomic number gives the neutron, or mass number minus your proton or electron number. If you are separating, it will give the neutron. Then tell me,
Sir, then 3 neutron.
for lithium 7, 3 lithium 7, 3 is the mass number, sorry, atomic number, 7 is the mass number. You tell me that neutron, proton, electron.
Sir, 3 protons, 3 electrons, then it will be 4 neutrons. If it's 7, right?
Now, very good. So for 2 He power 4 helium atom, for the helium atom,
Yes, sir.
Sir, I'm not able to understand, sir.
just a minute, I will draw just what you are understanding. I'm asking the question. So 2 He power 4 means 2 is the atomic number, 4 is your
Yes,
mass
sir.
number. Okay.
Yes, sir. 2 electrons, 2 protons will be there.
For 7N14, 7 is the atomic number, N is the nitrogen atom, 14 is the mass number.
Sir, can repeat it?
7N14.
Sir, for which one?
For the nitrogen atom.
Oh, nitrogen.
Nitrogen atom.
Sir, I'm not able to understand, sir. No,
Sir,
sir.
14 is the mass number, sir.
Yes, yes.
Sir, we have to subtract the mass number from, we have to subtract the atomic number from mass number, sir.
Yes, yes, yes. Just a minute. I'm connecting your iPad. Okay. Yes, you calculate and tell me.
Sir, 7 neutrons.
Hmm?
7 neutrons, sir.
Correct. Just a minute, ma.
Recording in progress.
Wait a minute. I will share my screen. Now you could see the screen.
Yes, sir.
Now we are calculating for
Nitrogen.
7 nitrogen proteins. So when you are considering atom, okay, so it consists of number of,
7 protons,
so generally proton plus
neutrons.
neutron plus electron.
Sir, but electrons is negligible, right?
Wait. So when you are concentrating about the atomic mass, so number of proton or electron plus number of neutron. Okay, so the atomic mass, we are call it as Z. Okay, so when you are so this is the symbol of your atom. Okay, whatever they are putting here, no subscript or superscript, so this corresponds to atomic number. Here whatever mentioning here, it corresponds to mass number. Okay, so Z X J means it's a atomic number, it's a mass number, it's a atom. Okay, clear? Now I am writing potassium 1940. So this is your, what is this? What is this?
Mass number.
This is
Mass
Atomic.
number. The atomic number. 19 is atomic.
now you have to calculate number of proton. So I told you number of protons.
So number of neutrons are 21, number of protons are 19.
So atomic number is equal to number of proton. Okay, so what is that? 19 proton, electron,
19 electrons.
neutron,
Neutrons is 21.
40 minus 19,
21.
okay, 20 calcium 40. Tell me.
Sir,
20
20
protons,
neutrons,
20 electrons,
20
and
neutrons,
20
20
neutrons.
electrons.
Everything 20.
20.
Proton,
20 proton, 20 neutron, 20 electrons.
92 uranium 235. Tell me.
Sir, 92 proton, 92 electron, and 1 minute, sir.
Calculate.
So 143 neutron.
143, sir.
143
Neutrons.
238 means
238,
238. Uranium 238.
238, sir.
145 neutrons
Yes.
will come.
145.
145.
So now you understand how to
146,
calculate
sir. 146. 146.
146.
Hmm.
Yeah, sorry, 146.
Correct. 140. 140. Anjumani. Okay. So now. So now we got an idea to calculate number of proton, number of neutron, and number of electron. Correct? The next problem. Is to write the electronic configuration of all the atoms. Okay.
Sir, what is electronic configuration?
Just no, the atom means you have the nucleus. Around the nucleus you have a circular path. Okay. So
the structure.
what?
Find the structure of an atom. Electron configuration.
So this is the nucleus, ma. Okay. So in the nucleus you have proton and neutron. First shell you have some certain gaps. In the second shell, third shell. Okay. Then fourth shell. So this is what we are saying: K shell, L shell, M shell, and N shell, and so on. Okay. The K shell. So it's a circular path. Okay. That's why we call it as it's an orbit. Okay. In the orbit, so revolved around the nucleus. In the orbit only, the electron going to be present. The orbit only, electron going to be the present. So when you are when the electrons are present, no, here it has some shapes. What we can call it as orbitals. Okay, in the orbit, you can find the probability of finding electron will be there. So that is known as orbital. Okay, so the orbitals are classified: s orbital, p orbital, d orbital, and f orbital. So how they are classifying orbitals? S orbital, p orbital, d orbital, and f orbital. So the electron going to be present any among this orbital. Okay, it can be s, p, d, f. So based on their energy level, it going to fill. Okay, are you follow me? It's a nucleus.
Yes, sir.
The nucleus you have the circular orbit. In the orbit you have the orbital. So orbitals are the electron were present. Okay, so they call it as s orbital, p orbital, d orbital, and f orbital. It's nothing but short, principal, diffused, and fundamental. The meaning of this: short, principal, diffused, and fundamental. So next year you will study about the structure of orbital. So the s orbitals are spherical in shape, p orbitals are dumbbell in shape, d orbitals are double dumbbell in shape, and f orbitals are in the 3 dimension. It's very difficult to draw the f orbital. Okay, that is also having dumbbell like shape only. Okay, now the electrons are present.
Sir, I have one doubt, sir.
Yes, ma'am.
Sir, cathode is usually negative, right? But cation is positive, right?
Yes.
Why is it? Both are cathode.
cathode is different from cation. Okay, cation means when the ion which is positively charged, that is called cation.
But cathode is negatively charged.
Okay, ma, it's a name only, no?
Okay.
Then when you are having cathode, you are passing under the electrode. Okay, so negatively side you are giving, that's why cathode you are saying negative, anode you are saying positive. Okay, but cation is different from cathode. It's not equal to cathode. Anion, it's not equal to anode because cations are positively charged ions. For example, Al3 plus, Cr3 plus, CO3 plus, H plus, C plus, like that. Anions are negatively
Minus.
charged ions. So H minus, Br minus, Cl minus, OH minus, like that it will be. Okay. So don't confuse your cathode and anode with cation and anion. So when the electrode charge you are given no positive electrode or negative electrode chosen based on that. When you are coming to the electrochemistry, the terminology will be different. Okay.
Okay.
You are applying potential or it create a potential. So based on that, the cathode, anode, positive and negative side will vary. Is it okay?
Okay. Sir.
So the cation is not equal to cathode, anion is not equal to anode. Okay. So
Okay,
some of the metal can behave as a cathode as well as it behave as a anode. No problem. Whether the electron is accepted or electron is given out. Based on that only it will react. Okay. Generally, what they will say at cathode, reduction will take place. At anode, oxidation will take place. This is what we will learn from the electrochemistry. Okay. So no, leave that one. Now your doubt is clear.
yes, sir.
So now, when the electrons are arranged in a particular circular orbit, that is called electronic configuration. Okay, so we cannot take the electron and we cannot put it into a particular orbital because all the orbital having particular radius, right? From here to here, here to here, here to here, here to here. Then it has a radius, mean definitely it has different energy. Am I right? So this is the outermost shell. This is the last but one. This is last but two. It is the nearest shell. So nearest shell is called K shell and the outermost shell is called N shell. You are not considering about the proton, neutron and electron. Simply if you are considering an atom, the nucleus will be in the center of the mass. Okay. So around the nucleus, you have the electrons. Okay. The electrons are distributed. Okay. It revolves around this particular circular orbit. Radius okay, va? Is it clear?
Yes, sir.
Now we are going to write the electronic configuration. So what is electronic configuration? So the electronic configuration is nothing
Sir,
but
electronic configuration on the first shell on the 2 electron இருக்கணும், second shell 8
so the
electron இருக்கணும்.
distribution of electron in a different shell of the atom is called electronic configuration. Okay. So otherwise, the electronic configuration gives an idea about total number of electrons present in that. So when you are concentrating electronic configuration, what is electronic configuration? So distribution or arrangement of the electrons in the differential shells of atom is called electronic configuration. So it gives an idea about total number of electron present in the atom and then maximum number of electron can be present in each shell. Maximum number of electron present in each shell. So these are the things we can calculate. So based on the electronic configuration, it will be based on n plus L rule or Bohr-Bury rule. Bohr rule and then n plus L rule. Okay, first you should know these rule, then you can write the electronic configuration easily. So what are the rule? No, first is of so maximum number of electrons present in each shell that can be calculated by using the 2n squared formula. Maximum number of maximum number of electrons present in the shell can be calculated by using 2n squared, where n is the principal quantum number. Okay, so nothing but you are taken, no, this is the first one, no, this is 1, this is 2, this is 3, this is 4. That means n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. Shall we proceed for the n is equal to 1 and 2 and 3 and 4? So this is the shell. So by using 2n squared, we can calculate for the K shell. K shell n is equal to 1. When you are substituting here, how many you will get? 1 squared 1. 2 into 1 squared. That means 2. Okay. Say yes or no.
Yes, sir.
And L shell, what is the n value?
2.
K, L, M, N. 1, 2, 3, 4 n value. Okay. So n is equal to 2. So 2 into 2 square. Then it becomes 2 squares are 4, 4 twos are 8. And then M shell. N is equal to 3. 3 square into 2. It becomes 3 square means 3 3s are 9. 9 twos are 18. And N shell, N is equal to 4. 2 into 4 square. So 16 into 2, 32. Okay.
Yes, sir.
So you can accommodate in the K shell 2 electron, L shell 8 electron, M shell 18 electron, N shell 32 electron. Okay. Is it clear? So
Yes, sir.
when you are arranging an electron in the shell, you should know about the quantum numbers. So the quantum numbers gives an address of electrons. So where the electron present, what is the energy of the electron, how many electron is present in the particular orbital, in which orbital electron is present, whether the orbital is magnetically, the spin is opposite spin or parallel spin, everything you can calculate by using the quantum numbers. What is the quantum number? So the quantum numbers are called principal quantum number, number 2 azimuthal or subsidiary quantum numbers, and then magnetic quantum number, and then spin quantum number. These are the 4 quantum number gives a better idea. So the principal quantum number generally called N, azimuthal quantum number generally called L, magnetic quantum number called M, spin quantum number called S. Okay. The principal quantum numbers are, it tells about the energy. So here you can calculate by using the 2n squared formula. How many number of electron present in the particular shell you can calculate by using this. Okay. So for the azimuthal quantum number or subsidiary quantum number gives how many orbital present? How you can calculate? By using n minus 1 rule. So L gives how many orbital present that it gives. Okay. When the L value is 0, 1, 2, 3, it tells s orbital, p orbital, d orbital, f orbital. We'll calculate for this. N is equal to 1. Okay. What is the L value? L is equal to n minus 1, no? So 1 minus 1 become 0. Then it is a s orbital. Okay. And then n is equal to 2. What is the L value? 2 minus 1. It become 1. 1 means 0, 1. Then you have s and p orbital. So what I am saying, 1 means that is p orbital. And n is equal to 3. L is equal to 3 minus 1. It becomes 2. So 2 means it's a d orbital. N is equal to 4. L is equal to 4 minus 1. It becomes 3. That become f orbital. So first shell you have s orbital. Second shell additionally you have p orbital. Third shell additionally you have f orbital. And fourth shell it has f orbital. So now I'm telling n value 1 means s orbital, 2 means p, 3 means d, 4 means f. You have to come to the conclusion, no? So only f orbital is present? No. So it explain about the magnetic quantum number. Magnetic quantum numbers are give minus L to 0 to plus L. So when the L value is 0, M value is 0. When the L value is equal to 1, M value become, solunga, by using this.
Sir, 2.
L value is 1, M value become how? Minus L, 0 plus L. So minus 1, 0 plus 1. So L value is 2. Then M value become?
Minus 2, 0 plus 2.
No, minus 2, minus 1, 0, plus 1 and plus 2. So L value is 3. Then M value become?
Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3.
So you calculate. Here you have only 1. Correct? Here you have 3. Here you have
5,
5. Here you have
8.
7. When the L value is 0 means what orbital we said?
N.
L
Yes,
value
S
0.
orbital.
L value 1 means?
L value 1, p orbital.
Correct? Huh? Is it correct?
Correct, sir. Correct, sir.
You arrived, no? That finally spin. So the electron can spin in the clockwise manner or it can spin in the anti-clockwise manner. So the spin will be plus of or it will be minus of. Okay. So this is about the quantum numbers. When you are filling the orbital, you have to follow alpha principle or n plus L rule. Principle. Hund's rule for the maximum multiplicity. Pauli's exclusion principle. So when you are filling the electron in the orbital, you have to follow this rule. N plus L rule is nothing but based on the energy only you have to fill the orbital. So உனக்கு என்ன தெரிஞ்சு போச்சு? First shell இப்போ வந்து n value, L value, M value, S value you can put. N is equal to 1 means L is equal to 0, M is equal to 0. Correct? And S equal to 0. And 2 power n square, total number of electron, that becomes 2. Correct? So you have only s orbital. In the s orbital, you can accommodate only 2 electrons. Then you are coming to the n is equal to 2. L become 1. That m become -1, 0, +1. Correct? Then totally you have 8 electron. So that means you have 0, 1. L value n is equal to 2 means you have 0, 1. 0 means s orbital. -1 plus 0 plus 1 means p orbital. So totally s. So you have s orbital and then p orbital. Epo when n is equal to 2, that means k shell, l shell, and n is equal to 3, m shell. 0, 1, 2, because 0 to n minus 1 l value. This is minus l, 0 plus l. Okay, so it becomes 0, -1, 0 plus 1, and then -2, -1, 0 plus 1 plus 2. So you have totally 3 power 18 electron. So s orbital, p orbital, and then d orbital. 1, 2, 3, 4. Then 4 n 0, 1, 2, 3. Then 0, -1, 0 plus 1. Then -2, -1, 0 plus 1 plus 2. Then -3, -2, -1, 0 plus 1 plus 2 plus 3. So totally how many electron?
32.
4 means 32, right? So s orbital, p orbital, d orbital, and f orbital. You calculate all this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So you got no how to fill that electron. Is it clear?
Yes, sir.
Now, when the rules of our principle says, so first shell you have 1s orbital, second shell you have 2s and 2p orbital, third shell you have 3s, 3p, 3d orbital, fourth shell 4s, 4p, 4d, and 4f orbital. Correct, Amma? And the fifth shell 5s, 5p,
5p,
5d, 5f orbital. So the electrons energies are going like this orbital energy. So first you have to fill the s orbital, then you have to go to the 2s orbital, then you have to come to the 2p, 3s, 3p, 4s, 3d, 4p, 5s, likewise. So now you can ask, so if you are writing, so what you are getting, 1s orbital is lesser energy than 2s orbital, then 2p, 3s, 3p, 4s, 3d, 4p. So when the question comes in your mind, why 4s orbitals are before 3d orbital? Question vandudha illaya mind la varalaya?
இல்ல சார்.
ஏன் வரல? Looking here, 3 தான் சின்னது, ஏன் 4 முன்னாடி போட்டு 3 பின்னாடி போறோம்? அதாவது that means if you are filling the electron, first 2 electron you have to fill here, then you have to go here, then they here, then here, 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 here. So the question comes in your mind, why 4s orbital get filled over the 3d orbital? Question vandha?
yes sir. வந்துச்சு சார்.
n plus l rule follow பண்ணுங்க. n ங்கிறது principal quantum number, l ங்கிறது azimuthal quantum number. உனக்கு தெரியும் l value 0 னா s orbital, l is equal to 1 னா p, l is equal to 2 னா d, l is equal to 3 னா l is equal to 3 means it become which orbital? So only you have 4 orbital.
F sir, F.
So now n plus l value. So for 1s orbital, n is equal to 1, s L value 0. For 2, 2 plus 0. For 2p, 2 plus, for the p orbital, what is the L value? What is the L value for 2p orbital?
Sir, 1 plus 0.
So the for 3s orbital, 3 plus 0. 3p orbital, 3 plus 3 plus
3 plus 1
4s orbital, 4 plus 0.
plus
For
0.
3d orbital, 3 plus, what is the L value?
Plus 2. 3 plus 2.
For 4p orbital,
4 plus 1.
4 plus.
1.
So now you calculate 1, 2, 3, 3, 4, 4, 5, 5. So next question comes in your mind. What is the question? What is the question? Here both are 3. Why you are getting 2p orbital lesser than the 3s orbital? What reason for this and this and this and this?
Sir,
Explain, Manal.
they have same energy as sir.
So when n plus L calculate பண்ணீங்கன்னா, you are getting the same magnitude, right? And the magnitude is same means, so you can put the equal symbol, no? But we are filling the 2p orbital, then only we are going for the 3s orbital. What is the reason? It may be, what may be the reason? What may be the reason? Yesho. Yesho?
Sir,
Tell me. Here 3, here 3. Why you are filling 2p orbital before the 3s orbital?
sir, I don't understand. Can you repeat?
Huh?
Can you repeat? I didn't understand. Say that.
So why 2p orbital get filled over the 3s orbital? Or why 2p orbital filled before then 3s orbital? Or 4s orbital filled before the 3d orbital?
Sir, because 4 plus here you wrote it n plus L. 4s has a lesser number like 4 electrons and it's before itself. That's why it was filled before.
So okay, for 4s and 3d you explain. What about 2p and 3s? And 3p and 4s?
3p and 4s.
Hmm.
Sir, both have like same number of electrons. The first number is 3, right?
Very good. So the shell, this is what near the nucleus. It's far away from the nucleus. Okay. When the
Yes,
3
sir.
means, so third shell. 4 means fourth shell. That's why it gets filled over. Is it clear, my all of you?
Yes, sir.
Sir.
Now, how many electron you can accommodate in that s orbital? So s orbital you can accommodate only 2 electrons. P orbital you can accommodate 6 electrons. D orbital you can accommodate 10. F orbital you can accommodate
12,
14.
14, yeah.
Because s orbital 1, p orbital 3 magnetic quantum number, d orbital 5, and f orbital 7.
7.
Okay.
Yes, sir.
So this is now The atomic number, you tell me some atomic number, we will fill it up the electrons. Yaarachu
Any-
atomic number tell me. Huh?
One,
Any atomic number.
Yes.
one.
1 means only one electron. Then the electronic configuration become 1s1. Then K shell you have only one electron.
72.
ஒரே ஐடியா ஒரு 20 25 30 குள்ள சொல்லு அப்பதான் ஈஸியா இருக்கும் இதுல.
Okay, sir. 33.
33. So when you are filling the 33, so 2 electron for s orbital, how many electron you can fill? S orbital, how many electron? 2 electron. 2, 4, 6, 2, 6, 2. You calculate
10.
2 plus 2, 4,
4, 10,
10,
8, 18, 20,
20,
30.
30, and then 3. So the electronic configuration become 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Correct? Now K shell, how many electron you have? L shell, M shell, and N shell. K shell, how many electron?
2. 2 electrons.
Second shell, L
8
shell,
electrons.
M shell,
8, right?
no,
16.
8, 10.
No, sorry, 8, 10, sorry.
And N shell, and N shell. 2 plus 3,
The 2 plus 2, come on, 5, right? 5. 5.
okay. Is it clear?
Yes, sir.
So this is how you have to write the electronic configuration. Now all of you write one electronic configuration. For magnesium, 12 Mg24. You have to calculate number of proton, number of neutron, number of electron, and electronic configuration.
Okay, sir. Number of electrons and protons is 12.
Electrons,
Protons
how
is
many
12.
electrons?
12.
Proton,
12. Neutrons, 12.
so 12, 12. Then electronic configuration in K shell, L shell, M shell, N shell. The K shell totally how many electron you can accommodate? You
2,
don't
sir.
forget this
2.
one. You don't forget this one. 2, 8, 18, 32. Okay?
Yes, sir. Yes, sir.
K shell 2, L shell 8, M shell 18, N shell 32. So you tell me 2,
K shell will be filled. L shell also will be filled.
10,
M10 will come, then that 2 in M shell.
So when you are writing the electronic configuration, 1s2, 2s2, 2p6, 3s2. Okay? So other person, tell me about that phosphorus. You tell me the electron, proton, other person who is present.
Sir, Sai Siddhartha, sir.
Anyone?
Sir, electrons is
There are only
No. Yesho, there are?
Sir, there are only 3 students, sir.
What about others?
No one joined, sir.
sir, only V3 joins, sir. Me, Sai and Giri, sir.
No problem. Those who are in the online, you tell. So Sai, you tell me. Electrons,
Okay, sir.
15.
electron, proton, and
Sir,
neutron.
15 electron, 15 proton, and 16 neutron.
So what about the electronic configuration?
Sir, wait, sir, I'll say. K
Okay.
shell 2, L shell L shell 6.
Six
So 8. Sir, sir, இல்ல sir, நீங்க போட்டீங்க sir, அதனால தான் சொன்னேன்.
Sir,
அது
there
நான்
you wrote
போட்டா
6 no sir, 8.
you have to
Sir,
correct me.
Sir, 8, so 10 ஆயிடுமா? So M shell 5.
So when you're writing 1s2, 2s2, 2p6, 3s2, 3p3. So Girija,
Sir,
Yes,
arsenic.
you tell me ma for organ.
sir, actually I didn't get the concept.
Very good.
I was trying to unmute myself, but I couldn't.
Now I asked the question, that's why you unmuted and telling.
No, sir.
Ah.
I joined late because of some network issues, and I didn't want to interrupt the class, so I didn't stop you in the middle.
Okay. So if you want to calculate number of proton, neutron, electron, first you understand the atomic number is equal to number of proton. Okay, or otherwise number of electrons. Okay. So atomic mass equal to, that is number, atomic number. Atomic mass equal to number of proton plus number of neutron. Okay, va?
Okay,
Girija.
sir. Yes,
So
sir.
this is your atomic number. This is your atomic mass. From this, you have to calculate number of proton, neutron, and electron. So number of electron first you calculate. Number of electron is equal to,
Sorry, sir.
so number of electron. So you have what is the number of electron or number of proton is equal to atomic number, correct? What is the atomic number? What is the atomic
Sir,
number?
the
Ma?
atomic
18.
number is 40.
18.
Isn't it
So
40?
this-
Oh, sorry,
this is
18. Sir,
mass.
yeah.
This is mass. This is number. Atomic number, atomic mass. This is the atom. So number of proton become, proton and electrons are same. So now
It's
tell
18
me,
again.
neutron.
Neutron equals to number of proton,
Plus
atomic
number of
mass.
neutron.
So we can, from
40
atomic mass, we
minus-
can minus proton, right?
What is the proton
40
value?
minus 18.
What is that?
22.
So 22 is the neutron, 18 is the electron, 18 is the proton. So now you subtract in electronic configuration. K, L, M, N. K you can accommodate 2, L you can accommodate 8, here 18, here 32. Okay, totally. So totally how much you have? 22, right? So you fill it
Yes,
up.
sir.
2, 8, 10.
Again
So
8.
10 to the remaining 12 is there. So N becomes 12, right?
So then,
Sir, 8, sir, M shell should be, M shell should be 8. Two
plus 8, 10, 10 plus 8, 8. Okay. So when you are writing the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6. Okay.
okay, sir. Yes, sir.
So now you try for this element. 20 calcium 40. You tell me.
Sir, proton is 20,
Hmm.
electron is 20, and also neutron is 20, sir.
20. So K element.
It will be 2.
Hmm.
L element is 8.
Hmm.
And M will be 10, sir.
Three S2, 3p6, 4s2. So 10, 18, 20. Okay. So you calculate the superscript. If you are adding everything, it will give the atomic number. Okay. So next class, we have to solve the problems in this unit. Okay. So only one thing I want to tell you is isotope, isobar. What is the difference between isotope and isobar? So we will wind up to this and isobar. So isotope means same
atomic number and element but different mass number.
different
Mass number.
mass number, or otherwise number of proton is
Neutrons.
same.
Neutrons different.
So number of neutron
Different.
when you are coming to the isobar,
Different elements have
different
same mass
atomic
number but different atomic number.
different atomic number, same mass number. That means what?
The
Number of
different
proton,
elements have different.
number of proton different, correct? And number of neutron
Number of neutrons are same, sir.
how the
Sir, because same mass number.
Same
Same mass number.
So I'm telling 18 argon 40. Okay, 19 calcium 40, 20 calcium 40. You calculate for that. Proton is 18, 19, 20. Neutron is 22, 21, and 20. No,
Yes, sir.
what you said that?
Sir, I said they're different, sir, because the mass number is never going to be same.
See,
Because neutrons will be.
from this part, if you are seeing, it will become reverse. Okay, but when you are coming to the actual part, they are different. Frida, same atomic number, different atomic number, different mass number, same mass number. Number of proton same, number of proton different. Number of proton neutron different, number of neutron different. Is it clear?
Okay, sir.
So you tell me, I will write some of the examples. 18 oxygen 16. 18 oxygen 18. Whether it is a isotope or isobar.
Isotope.
Why it is isotope?
First of all, it's the same element, and second, the mass number is the one which is same.
That's why it is a
Isotope.
okay. Correct.
Fluorine, sulfur. Sulfur is also same.
Now,
Sir, this it's again isotope because they're both the same element, and again mass number changes.
so now you got that point, right?
Yes, sir.
So now one more point, that is isotone. What is isotone? Iso means same.
So means same, yeah.
Okay. So isotone are different element with the same number of neutron, but it may differ atomic number, differ mass number. Okay. So same number of neutron is called isotone, are called isotone. So now I will write some of the pair you have to identify. We will take our example from our book itself.
Sir, last time we were doing right. Last chemistry class, the before 1 year, right? That time also we had same neutrons. We calculate. I think it's chlorine and argon. I think.
That is an atomic mass we have discussed, right?
That day you also calculated the amount of protons. You were like telling us.
So, okay, no problem. Now you tell me this. Six carbon 14, 7 nitrogen 14, and 9 fluorine 17. So, which is the isotope, isobar, isotone you have to identify? So, isotope means same atom, different mass number. So, it's not a isotope. Isobar means same mass number, different atom. Correct?
Yes, sir.
So, according to that, these two will be
Sir, these two will be same. This will be like isobar.
hmm,
The next one will be isotone. The below one.
this one.
Yes, sir.
Okay. So you calculate number of neutron in all the case. Here
Sir,
difference is
even the third one also is an isotone, sir. The fluorine.
here, no?
Fully. Yes, sir.
Because the difference is 8,
8,
8,
8 and 8.
8. So number of neutron is same. That's why it is a
Isotone.
isotone. Is it clear?
Yes, sir.
So next class we have to revise this unit more. Now whatever doubt you are having, you tell me.
No
So
doubt,
what
sir.
we have learned, the subatomic particle, neutron, proton, and electron. So neutron is discovered by the scientist Chadwick. Okay, the symbol is called 0n1. Okay, their mass as equal to that of your proton. That's
Proton,
why
but heavier.
but they are not affected in the electrical and magnetic field. That's why they called as neutral. When you are coming to the proton, proton was discovered by the Goldstein. So the symbol will be 1H1 or P plus. Okay, small p plus. So charge is a positive charge. Then masses are 1. Okay, so it can travel in the straight line, but it deflected in the presence of electric and magnetic field. In the direction opposite to the cathode rays. Cathode rays na another. Cathode rays na positive or negative? Negatively charged, no? Cathode rays na?
Yes, sir.
So it will deflect in that way. Okay. So direction opposite to the cathode rays. And when you are coming to the electron, it was discovered by the J.J. Thomson. The symbol is E minus. So it has the charge. It can also travel in straight line, but it produces mechanical effect also. It can be deflected in the presence of electrical magnetic field. So it produces X-ray on the striking the metal targets. That's why we are getting the X-ray and all. That can be calculated by using Geiger-Müller count use funny. You can calculate the mass of your electron and proton. And we were discuss about the model. There are 3 model. One is J.J. Thomson or plum pudding model. So they said spherical positive charge. In that you have electrons are embedded like watermelon. Okay, watermelon the seeds are சொன்னாங்க. But the assumption is wrong. It was verified by the
Sir?
Rutherford. Yes.
Yesterday you showed one video in the class, right?
Yes.
Yeah, may I know which channel is it from?
Which channel? Do not memorize.
So they have all like chemistry concepts in them?
No. It's not given all that. That experimental, the beautifully given. That's why we have chosen.
Okay, sir.
That concept, only some of the channels, certain concepts are good. Certain concepts are not acceptable. Okay. So if it is right, we are providing that videos only we are providing. Okay. But could you understand that videos?
So
But
the visuals were nice. So
that's why. Because if I draw that picture, I'm showing it was deflected, it was passed through like this, means it will not give a given clear picture. That's why I chosen that video. Okay. And then Rutherford model comes to that then they given basic fundamental of your model, but it also their own demerit. Then we went for the Bohr model. Bohr model gives, so each orbital of the particular energy. When the energy is gained, the electron will be ejected one orbital to other orbital. So that is called excitation. When the back to the orbital, it can emit the energy, then it is called ground state. So when the atoms are in the ground state means they have stable electronic configuration. When the energy is absorbing, it goes one orbital into another orbital. For example, 2s orbital electron will jump to the 3s orbital. You have to supply energy. So that is called excitation. So the excitation is not stable. So again, it back to the original state. That time, it can release their energy, then emit their energy and back to the original orbital. It's called, it's also, it is called ground state. Normally atom in the ground state, when you are applying energy or giving the energy, the particular energy absorbing, that particular electron is jumping to the next state. Again, it coming to the back state, no, it can emit the energy. That energy can be lighter, light நமக்கு தெரிஞ்சதுன்னா it shows the color. அவ்வளவுதான். ஓகேவா? So then atomic number na enna, mass number na enna, that we understand. Then isotope, isotone, isobar, that we come to this lesson. Okay, we learned from this lesson. Is it clear?
Yes, sir.
Okay, ma.
Yes, sir.
So we will wind up with this class.
Okay. Thank you,
The
sir.
next class we will work it out the problem in the direct class. Okay,
Okay, sir. Thank you, sir.
now we can leave.
Sir.
Sollu Siddha.
Thank you, sir. Sir.
Okay, ma. Thank you.